Hi everyone, and welcome
back.
So what we're going to be talking about today are ellipses. Not eclipses, ellipses. So first we're going to start off with a nice quick do now. So why don't you start with that? We're just going to sketch out a circle with a diameter of 10, centered at 1, 3, and then you're also going to write the equation of the circle. So if the diameter is 10, we know the radius is 5. Radius is 5. So I'm just going to draw in the point 1, 3. So that's here. That's my circle. And if the radius is 5, I'm going to travel 5 units to the right, up, down, and left. So let's sketch those points in. All right, so there's my circle. And now let's come up with the equation of the circle in center radius form. So we have x minus 1 quantity squared plus y minus 3 quantity squared is equal to the radius squared. And my radius is 5, so this will be 5 squared, which is 25. All right, so this should be nice and straightforward. Now we're going to move on to something that should be brand new for everybody. Now we're going to start talking about graphing ellipses. So this is going to be some pretty important vocab I'm going to go over. So if you want to grab a highlighter, whatever you need. So first things first. If I wanted to, I could stretch this circle, right? If I wanted to, I could pull these vertices of the circle and make it more oval-like. So maybe it will turn into something more like this, which would come up with now creating an ellipse. So that would be like if I stretched the circle out. And I could have also done that vertically. So instead, maybe I want to stretch these vertices out here. And again, maybe it will look more like this. So now it's being stretched out, where now I'll have foci. So a focus, there actually are 2 of them in an ellipse. All right, so let's take a look at some terminology here. So like I said, I could have stretched out the circle to form an ellipse. They're more commonly seen as an oval. Since an ellipse is just an elongated circle, there isn't just a center. There's now 2 foci and also 2 vertices. Really important to note, the foci and the vertices must lie along the major axis. The major axis is always the longest length from vertex to vertex. So the longest length across the ellipse. So this would be my major axis. Contrarily, this would be my minor axis. It's smaller. So that's the smaller side as I go from endpoint to endpoint on the ellipse. All right, so that would be the minor axis. Lots of vocab I'm going to be talking about here. So if you need to rewind any portions of this to make sure you have a good handle on this. All right, so yes, we'll have this center point along with 2 foci. So here's our center point right in the center. And then you'll have focus 1. So focus 1 and focus 2. Okay, the vertices are always along, I'll say it again, the vertices are always along the major axis as well as the foci. So the foci and the vertices are along the major axis. All right, I have those labeled. Again, we still indicate our center with the point H comma K, where there's your X value for the center and the Y value for the center. Now, an ellipse has a similar equation to a circle, but there are different aspects. So let's look at over here. Here's one of them, and here is the second one. And let's color code them. So this one will be in blue. So now what I have highlighted here in blue is an example of what this ellipse could look like. What I have highlighted here in red is an example of what this ellipse could look like. Notice the shift in where the major axis is. So for what I have drawn in red, here would be my major axis. So that's your major axis. Again, guys, you want to be taking notes here because you're going to be looking at questions like this. And then for what I have drawn in blue, here is now my major axis. And we're going to label also as well the minor axis. So the minor axis I'll label here in black. So that would be my minor axis. Right? There are 2 ways of looking at an ellipse. Could be either flattened or stretched vertically. So think about it like either being compressed horizontally or stretched vertically. There are two different ways we can look at it. All right, and then there's my minor axis. Now we're going to label each of these components. Okay, so center we know is going to be right here. So there would be my H comma K. Same thing here. I would have my center as H comma K. The length of the major axis. So we need to actually get into some labeling here. The length of the major axis is 2A. Well, you need to know what A is first. A is the length of the center to one of the vertices. So here to here, let me highlight it. From here to here is a length of A, and from here to here is a length of A. So let's write that down. From here to here is a length of A, and also here to here is a length of A. I'm going to get rid of right here just so there's not too much writing. Get rid of this HK because hopefully you guys know that already, that that's your center. All right, so this is also A. So the major axis is then 2A. And we're going to label on here as well. This is A, and this is A. Notice the difference in the types of ellipses we can be looking at. Now the minor axis is 2B. So from here to here would be B, and here to here would be B. From here to here would be B, and from here to here would be B. So let's label that. So this would be B, or this would be B. From here to here is B, and from here to here is B. All right, so that's the length of the minor axis. It's twice B. And now C is going to be the length of the distance from the center to the focus. So C is going to be the distance from the center to the focus. So let's label that. From the center to the focus, let's do that actually. Let's do it in green. So from here to here, that's C. From here to here, that's C. So again, from here to here, that would be length C. And from here to here, that would be length C. So C is the distance from the center to the focus. It's actually going to play a pretty important role. And C is defined to be the square root of A squared. So of that A squared minus B squared. So we're just subtracting those squares, okay? Make sure you have all of this information written down because we're going to need it as we continue on now to the next page. All right, so let's look. So we already talked about this. I'm not going to spend too much time going into this, but this is just further definitions. The ellipse, again, is just the set of all points whose sum is the distance that is constant from two distant foci. So you have one focus here, and you have one focus here, okay? What is the formula of an ellipse? Well, we already said that there are two of them. So I'm going to write them out just as additional practice for us, right? We had them written up here in red and blue. So let's just write them out again. Again, you want to get used to writing these out. So you have x minus h quantity squared over a squared plus y minus k squared over b squared equals 1. That's really important that it equals 1. And then I'll have x minus h squared over b squared plus y minus k squared over a squared equals 1. Now, I actually do want to go back really quick because there is something I did want to point out to you. Notice the difference in these formulas. I wanted to point this out. When x is being divided by a squared, that means the major axis is along the horizontal. So when x quantity of x minus h squared is being divided by a squared, that means the major axis is along the horizontal. Now, if you notice here, for this example, now x quantity minus h squared is being divided by b squared. That means that the minor axis is along the horizontal. So that means now the minor axis is along the horizontal. So B is the minor axis, A is the major axis. So if you notice in this equation, do you see how y is being paired with a squared? And A is the length or twice a is the length of the major axis. Well, because y quantity minus k squared is being divided by a squared, that means our major axis is vertical. So our major axis is going to be vertical when it's being divided by a squared with y squared on top. So I'll say that just one more time. When you have x squared being divided by a squared, that means the major axis is along the horizontal. Think about it as along x. And then when y squared is being divided by a squared, think about it as the major axis being along y. Okay, so now let's just come back over here. So for this example that I just did, and we just explained this, so that means this first equation would be representative of this ellipse. And then this second equation would be representative of this ellipse. That's actually going to be pretty important. So make sure you guys note that difference. When y is being divided by a, major axis is along a vertical line. When x squared is being divided by a squared, major axis is horizontal. Okay, so I actually do want to talk about this little portion right here, that an ellipse is a conic section with shapes made from taking the cross section of a cone. So if I were to sketch out a cone like this, one of the cross-sectional pieces, so if I were to look at something like this, okay, do you see how that is part of the cross-sectional area of a cone? So I can actually draw an ellipse, and I can draw more than just one ellipse. I can draw another ellipse here, being part of the cross-sectional area of a cone. All right, so that's where all of these conic sections are coming from. We talked about the parabola, we talked about a circle, right, because this would be the circle, cross-sectional area of a circular cone. Now we're talking about the ellipse, which these would be the cross-sectional areas. Okay, now let's actually get into some practice problems. So for this first example, you guys need to take note of the form that it's written in. So I have x minus 3 quantity squared all over. Now remember the formula is that it's over a squared plus b squared, or b squared plus a squared. So we're going to rewrite this instead of 16, I'm going to write this as 4 squared, just to be a little bit more helpful, plus y squared over 3 squared equals 1. This is actually going to be pretty nice for us to solve and evaluate because it's already equal to 1. You always have to have the equation of ellipse equal to 1. Well, very similar to the formula for a circle, our center will be at 3, 0. And now the length of the major axis. Remember, the major axis is bigger than the minor axis. Well, look at these values. Which number is bigger, 4 or 3? So we know that this is going to be our a squared value and this will be our b squared value because, again, a goes with the major axis, b is the minor axis. So I know from this equation here, a is equal to 4, and here we have b is equal to 3. But now remember, the major axis is 2a. So the major axis will be 2 times 4, which is 8. If I asked you for the minor axis, we would just say that the minor axis is 2b, which is 2 times 3, which is 6. Okay, so maybe we're looking at something like this, just to give you a little sketch of what we're looking at. Whereas this distance is a distance of 8, and this distance from here to here would be a distance of 6. Obviously, this is not drawn to scale, but just to give you an example. Okay? All right, let's keep going. So let's move on to the next page. So now we're going to graph and sketch the ellipse. We're going to find the center, the foci, the vertices, the length of the major and minor axis. So let's start off with the first one. And now notice, this is actually the exact same problem as what we just did before. So we already know that this is written as x squared over a squared plus y squared over b squared, where we said a is equal to 4 and b is equal to 3. This is literally the exact same problem, guys, from what we just did before. Very, very similar, just it's missing the x minus 3 squared, but that's okay. So we know that the length of the major axis is 2a. So this will be 8. Then the minor axis is 2b, which will be 6. 2 times 3. All right. We know that this is centered. This is centered at 0, 0. So I'm going to put a point right here. And if I know the major axis is 8, then I know that I'm going to travel 4 units to the right. 1, 2, 3, 4. Put a point. That's one of my vertices. And then 4 units to the left. I'm also going to travel 3 units up. 1, 2, 3 for the minor axis. And then 1, 2, 3, giving it total length of 6. So now we're just going to sketch in our ellipse as best you can. Okay, so there's my ellipse. Other parts we have to answer, so we know the vertices are along the major axis. So the vertices are along the major axis, which tells me then my vertices are here and here. So that's at negative 4, 0 and 4, 0. So the vertices are at 4, 0 and negative 4, 0. Okay. Next question we have to answer. We need to find the foci. So where are the foci? Well, remember, the equation for the foci is c equals the square root of a squared minus b squared. And we already know a squared is 16 and b squared is 9. So I'll have c equals the square root of 16 minus 9. And c is going to equal the square root of 7. So that's the length from the center to one of the focuses, or one of the foci. So c being rad 7, now that's approximately, if you want to think about that in terms of a decimal, would be 2.64575, blah, blah, blah. Okay, so if I were to sketch that in from the center, we're going to go 1, 2.6, so that's roughly here. There's one of the focus, and then 1, 2 here. That's the other focus. So there's focus 1 and focus 2. So those are my two foci. So if I ask for the endpoints of the foci, well, we went to the left by radical 7, so negative rad 7, 0, and we went to the right by rad 7. So those are my 2 points. All right. Again, guys, if you're having any trouble with this, you can always rewind any part of this that you need to revisit. Okay, let's take a look at the next example, example 2. All right, now you should notice an order difference here. So I'm actually going to rewrite this in the order that I like the way it's written, is x minus 3 quantity squared over 4 plus y minus 1 quantity squared over 25. If you need to, have that sheet out that shows you the different formulas. Now remember, the bigger number goes with the value along the major axis. So 25 is the bigger number, which tells me that this is really my a squared and this is my b squared. So I'm going to be looking at an ellipse that looks something like that on this axis. All right. So let's see. Well, we know b is going to equal 2 and a is going to equal 5. I'm just square rooting those numbers. Okay. So if I know a is 5, my major axis is going to equal 10, and my minor axis is going to equal 4. Remember, you just double these numbers. Okay. Where is this centered? It's centered. So the center is at 3, 1. So I'm going to put my center point at 1, 2, 3, 1. So there's the center. Okay. And I'm going to sketch in because we know that our b value is 2 and our a value is 5. Remembering that the major axis will be vertical. So I'm going to go up 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5. And then the minor axis is horizontal, so I'm going to go 2 to the right and 2 to the left. And I'm going to draw in my ellipse as best as I can. All right. And we want to now determine the location of the foci. So remembering that equation is c is equal to the square root of a squared minus b squared. We know that a squared is 25, b squared is 4. So I have 25 minus 4. So c is equal to the square root of 21. Now that's the length of from the center to one of the foci. So that's the length from the center to one of the foci. And this is approximately, if you want to think about that in terms of decimal values, is 4.58 ... So I'm going to travel 1, 2, 3, 4.5 roughly-ish. So there's one focus. Go down 1, 2, 3, 4.58-ish. There's my other focus. All right. Now we want to find the end points for the foci. Well, they're both along the x value of 3, right? That's when x equals 3. So let's write that in. Now that we know that the length from the center to the one of the focus, we want to now come up with those coordinates. So we already established that the x value is at 3. So we'll have 3 comma something and 3 comma something. And now we know this is centered at 3, 1. So this is already pushed up one value along the y-axis. So one of my values will be 1 plus radical 21. And my other value will be 1 minus radical 21. Okay, so those are my two foci. Those are the points for the foci. All right, let's take a look at a few more examples. So I want to actually scroll all the way to question 4. So let's take a look at question 4. Now you should notice that this is not equal to 1. So in order for us to get this equal to 1, we're going to divide everything by 100. So I'll have x squared over 25 plus y squared over 4 is equal to 1. From this, I'm immediately able to tell that this is my a squared value and this is my b squared value. Okay, so then I know a equals 5, b equals 2. So my major axis will be horizontal, my minor axis will be vertical. We also know that this is centered, so the center is at 0, 0. So let's draw that in. And again, we know our major axis. I'm going to go 5 units to the right and then 5 units to the left. 1, 2, 3, 4, 5. My minor axis, I'm going up 2 and then down 2. So I'm going to connect those with a nice smooth oval. All right. And now let's start to label our vertices. So the vertices are along the major axis. So I have one vertice here and the other one here. So that's at 5, 0 and negative 5, 0. So those are my vertices. Okay. We should also probably label here. We know the major axis is going to be 10. So the major axis is going to be 10 because we double the a value. We know the minor axis is going to be 4 because we double the b value. Okay. And we want to come up with now where the foci are located. So remember that formula for the foci is we have c equals the square root of a squared minus b squared. We have c equals the square root of a squared minus b squared. So I have 25 minus 4. Which is square root of 21. We know that the square root of 21 is approximately, I believe we just said that before, is 4.58. So that's approximately 4.58. So I'm going to travel about here for one of the foci, and then here for one of the other foci. And to just label what the actual endpoints are, we're going to label our foci 1 and 2 have the following coordinate values at negative radical 21 comma 0 and radical 21 comma 0. All right, guys, so this is all the information that we need for this question. All right, so let's take a look at just graphing one more of these. So why don't we take a look at question 6. So let's go all the way to question 6. All right, so again, we got to look at the way that this is written, taking a note to which direction the major axis is going to be facing, whether it's horizontal or vertical. And because the larger denominator is with x, we know that this is my a squared, this is my b squared. So we know that a is going to equal 5, b is going to equal 3. This is centered at -3, -2. So let's draw that in, -3, -2. There's my center. All right. And again, we know that the major axis is going to be horizontal, so I'm going to travel 5 units to the right and 5 units to the left. I'm going to travel 3 units up, 1, 2, 3, and 3 units down, 1, 2, 3. And now I'm going to sketch my ellipse as best we can. Okay. Next piece of information we should also probably list is the length of the major axis. So remember, the major axis is twice the value of A. So twice the value of 5 is 10. The minor axis is twice the value of B. So my minor axis will have a length of 6. We can also come up with what the vertices are, because the vertices, remember, the vertices are the coordinate points that are along the major axis. So that's here and here. So let's see what those values are. That's at 2, -2. And I'm also at -8, -2. So those are my vertice coordinate points. So let's write that down. And we're also at 2, -2. Now we also need to come up with what the length is for the focus. So the length of the focus, remember, is c equals the square root of a squared minus b squared. And we have c is equal to the square root of 25 minus 9. And 25 minus 9 is 16. So I have the square root of 16. And, ooh, this one worked out nice. So the length of the focus is 4. So I'm going to travel 4 units to the right from the center. 1, 2, 3, 4. There's one of the foci. And I'm going to travel 4 units to the left from the center. There's my other focus. Awesome. So let's write down those coordinate points. So the focus coordinate points are going to be at -7, -2, and 1, -2. And I believe we have answered every single component of this question. Awesome. All right, very cool. Guys, if you want more practice with this stuff, I mean, feel free. There are a bunch of other problems on here. All right, so we're going to start to wrap it up a little bit. So let's take a look at exercise 2. Again, I apologize for the lack of space. I should have included more, but we're going to take a look at exercise 2, and we're going to come up with the vertices, the focus, and then the length of the major axis. Now, there's a reason why I had you guys practice how to complete the square, because it's leading to this moment, this very moment. We're going to need to complete the square here. So I'm going to need a lot of space, so I apologize. So I'm going to be writing all over the place here. So let's write this out. Let's write it out in a better form. So I have 4x squared minus 8x plus blank plus 9y squared plus 36y plus blank is equal to -4 plus blank plus blank. Okay. We're going to start to complete the square. Let's first take out our GCF. So we're going to have 4 times x squared minus 2x plus blank plus 9 times y squared plus 4y plus blank is going to equal -4 plus. Now be careful. Do you guys notice how I took out here a 4 and a 9? That needs to be included outside here and here. So let me rewrite this a little bit better. So that needs to be included outside of those boxes. So that will be plus, and that will be here. All right, so the 9 has to be here, and then the 4 also has to be out front here. So we're going to include a 4, and we're going to include 9. Okay, those need to be included. All right, well, let's start to complete the square here. So I'll have 4 times x, half of 2 is 1 squared. 1 squared is 1, so we'll have 1. Again, complete the square, 9 times. I'll have y plus half of 4 is 2, so this will be plus 4 plus 4. This is going to equal all on the right-hand side. When I multiply and add this all together, we'll just be left with 36. Now, you guys should notice, we have to get this into the equation of an ellipse. So we're going to get the right-hand side equal to 1. So I'm going to divide everything by 36. Everything by 36 to get it equal to 1. And now I'm looking at x minus 1 squared all over 9 plus y plus 2 squared all over 4 is equal to 1. I'm going to clean this up, but make sure you guys have this equation written. So I'm going to erase what's on the screen. Make sure you have all this written, but this is how we complete the square. All right, now that we have our equation, we can come up with what the center is. So we know the center, so let's make a little sketch here maybe. So we know the center is at 1, negative 2, right? So this is centered at 1, negative 2. And our a squared goes with the 9. Our b squared goes with the 4. So I know my major axis, so for a, to get just the a value, my a value will equal 3, because we're just taking the square root of 9. So if my a value is 3, that means the major axis, so that means the major axis is equal to 6. So that answers this question here for part C. So I'm going to sketch. We have 3 units, 1, 2, 3. So I'll have a point here, and then 1, 2, let's see, 1, 2, 3. That's here. So those points for the vertices are at 4, negative 2. Sorry, 4, negative 2. And we're at negative 2, negative 2. Okay, so these are my points for the vertices. So that answers this question. And now we want to find the foci. So the foci, we got to use that formula where c is equal to, so we have c is equal to the square root of a squared minus b squared. We'll have c is equal to square root of, I have 9 minus 4. So c is equal to the square root of 5. All right. And we just want to find the coordinates of the foci. So if it's centered, so here's my center. The center is at 1, negative 2. Well, my foci are going to be at 1 plus radical 5, 1 plus radical 5, comma, negative 2. And my other one will be at 1 minus radical 5, comma, negative 2. So there are my coordinate points for the foci. And we've answered all the questions for this problem. Okay, and the last question that we're going to look at today, guys, is exercise 3. So gear up, we're almost done. Exercise 3. All right. So last question, what is the equation of an ellipse with a focus at 4, 2 and 4, negative 4, and then the length of the major axis is at 10? So I'm going to start by making a sketch. So I have my foci are at 4, 2. So let's see, 1, 2, 3, 4, 1, 2. And we have 1, 2, 3, 4. So I have 4, 2. And I have 4, negative 4. So that's the foci. Now remember, directly in the center will be the center of this ellipse. So the distance from here to here and here to here has to be equal. And we're going to label that letter C, right? Remembering from the center to the one of the focus is going to be the variable C. And now we can find C either algebraically or geometrically. And now I'm going to use the fact that C is equal to the square root of a squared minus b squared. Because I know that the length of the major axis here, right, the length of the major axis is 10. So that means 2a equals 10. So then that means we know a is equal to 5. So I'm just going to fill in. We'll have c equals the square root of 25 minus b squared. Now remembering c is that distance from the center to one of the foci. And from the center to one of the foci, well, let's see. We can figure out what the center is. Well, what's halfway between 4, 2 and 4, negative 4? Halfway between will be 4, negative 1. So that means our length of C to go from either -1 to 2 or -1 to -4, C has a length of 3. So I'll have 3 is equal to the square root of 25 plus b, or minus b squared, sorry. 25 minus b squared. I'm going to square both sides. So I'll have 9 equals 25 minus b squared. Subtract 25 on both sides. And I'll have -16 equals -b squared, where b is equal to 4. Okay, so we now know what C is, we know what B is, we have A. Let's get those vertices on the either end. So remembering, if this has a total length of 10, right, that has a total length from here to here is 10. Well, right now we're going from 2 to -4. To go from 2 to -4, that's a length of 6. So that means I need to go an additional 2 units up and 2 units below. Meaning my vertice here will be at 4, 4, and this one here will be at 4, -6. Because now that has a total length from 4, 4 to 4, -6, that now has a total length of 10. Okay? And while we didn't really need that information, I just think it could also just kind of be useful for you guys to see things like that. But now we can come up with our equation. We know that this is centered at 4, -1. So we'll have x minus 4 quantity squared all over b squared. And we know b is equal to 4. So this is really 4 squared, which is 16, plus we have the quantity of y plus 1 squared all over 25, because a squared, a is 5, so 5 squared is 25, and this equals 1. And guys, that's our equation for our ellipse here. Now, if you had a question about this, the reason why this is 16 and the reason why this is 25. Well, guys, if you look at our picture here, it's very obvious that our major axis is along a vertical line, and when our major axis is along a vertical line, that pairs with y. So that indicates that our minor axis of 8, that would technically be this way, of 8, that would be along a horizontal for the minor axis, which is why that pairs with x. Because the length of the minor axis is really 2b, and b is equal to 4, that really would have had a length of 8. Okay? Hopefully that clarifies why this equation is written as is. All right, guys, I hope you found this video helpful. If you have any questions, feel free to message me on Remind or set up a Zoom session with me. All right, I'll talk to you guys soon.